Hey, good day, good people. Let us look at the corrections of the test that we wrote. This was the question paper that we wrote, good people. And now let's take out the data, the given information. Question 2. Question 1, it was mainly you defining, you knowing the theory. Question 2, this is what was given. The plunger diameter, we are given the small d. It is 15 mil. We are given the stroke length, then we are given force applied to the plunger. This is FL. Then the diameter on the ram, big D. This is small d. Then this is stroke length. Now the first question that they want us to calculate, they want us to calculate the volume of liquid displaced after 5 strokes of the plunger. Now the volume, that would be volume plunger equals to area stroke length number of strokes. Now the area would be pi multiplied by diameter would be 0.015 squared divided by 4 multiplied by the plunger would be 0.12 multiplied by the number of strokes it is given as 5. Then it will be multiplied by 5. Then we get our answer. We get our answer as let's do it. It is pi times 0.015 squared divided by 4 multiplied by 0.12 multiplied by 5. Okay, we get our answer as 106,029, right, times 10 to the power negative 6 m cube. It's a volume. That would be m cube. Okay. Then the second question, this is question 2.1.1. This is how you tackle it for 2 marks. 1, 2. Then question 2.1.2. They want us to calculate the distance the ram moves after 5 strokes. The distance moved after 5 strokes. Then we'll be using this formula. Vp equals to VR. Okay. We've already calculated the VP. The VP, we've already calculated it. It is 106,029 times 10 to the power negative 6. They said after the distance the ram move after 5 strokes equals to, okay, equals to area ram 0.055 squared divided by 4 multiplied by h. Okay, then our h would be 106,029 times 10 to the power negative 6 multiply by 4 divide by pi multiplied by 0.055 squared. Then we get our answer as multiply by 4 divide by pi times 0.055 squared close bracket. Right, we get our answer as 0.0446. Let's make it 3 meters. Now if you were to take it to exponential, it will be, if you take it to exponential, then it's going to be millimil. Right, it's going to be, if you wanna write it in exponential, 44,628 millimeters. Okay, it's up to you. How do you want to tackle it? This is question 2.1.2. Okay, now if you've used the diameters, it was going to be the small d squared multiplied by stroke length, number of strokes, equals to big D squared multiplied by h. H would be small d 0.015 squared multiplied by 0.12 multiplied by 5 divide by 0.055 squared. Then our answer should be the same, 0.015 squared multiplied by 0.12 multiplied by 5 divide by 0.055 squared. It should be the same answer whether you use diameters or areas. 0.044628 meters. It should be the same answer. Now this is how you tackle question 2.1.2. This is how you were supposed to have tackled it. Now let's erase and do question 2.13. Let's erase. I hope you've seen the first answer there. Some of you can remember what you've wrote. Now you know what is it that you got there. Ne? Now let's look at 2.1.3. They want us to calculate the force exerted by the ram. It means they want us to calculate W. In calculating W, it will be W over FL equals to big D squared over small d squared. Then we have to make W the subject of the formula. Then it's going to be W equals to FL d squared divided by small d squared. Right. Then it will be, do we have FL? Yes, we do. There it is. It is 300. Now it will be 300 multiplied by 0.055 squared divided by 0.015 squared. Then we get our answer as, your answer there should be 4033 newtons. This is how you calculate 2.13. Now let's go to question, let's go to the following question. Now the whole question, come on good people, here you've lost marks because some of you didn't read the instructions carefully. 2.1.4, they want us to calculate the work done by the ram after 5 strokes. The work done. Now in calculating the work done equals to the work done, it will be force multiplied by H. Now, which force are we going to use? The question, it is clear we are indicated by the ram after 5 working strokes. Then it will be the force that we have calculated. That would be 0.4033.333 multiplied by the H that we have calculated, of which it is 0.044628. Then you get your answer there as 179.88 joules. Those who wrote it as 180, I did credit them. And those who gave me 181, I did credit them. It is within the tolerance. Now, this is how you tackle question 2.1.4. This is how you tackle it. I hope you can see where you've made your errors there. Now, let's wipe. Let's wipe so as to tackle the following question. Okay, Now, can I then wipe the whole, because question 2.2, we need to take out the data. Okay. Now let's look at 2.2. Let's take out the data, the given information. In taking out the data, they are saying the plunger of a 3-cylinder. We are dealing with pumps here. The number of cylinders connected to a crankshaft, it is what? 3. There it is. 3 cylinders. Has a diameter small d. It is what? 75 millimeters. Converted to meters, 0.075 meters. Okay, then we are given the stroke length. It is 250 millimeters. It will be 0.25 meters. Okay, then we are given pressure as well. There it is, the pressure. It is 750 kilopascal. Okay, now the first question that they want us to calculate, they want us to calculate the power required to drive. Now we are further given the information. We are given N, it is 150 R per minute. In second, it will be divided by 60. Then, excuse me, then we get our answer as, if we convert it to seconds, 150 divided by 60, we get our answer as 2.5 R per second. Okay, then what else it is given? We are as well given the efficiency, it is 75%. Now they want us to calculate the power required to drive the pump. They want us to calculate power in. Now how are we going to calculate power in? It will be efficiency equals to power out over power in. This is the formula that we are supposed to use. Now the question is, do we have power in? No, we don't have, but we are given everything that can help us to calculate power out. In calculating power out, would be power out equals to pressure multiplied by volt, volume per second, or rather volume per time. Remember, how do we calculate work done? Work done, it is pressure multiplied by volume. As soon as it becomes per time, it is no longer work done, but what? But power. Now, this is the route that we need to take in calculating what? Power there. Okay. Then power out would be pressure multiplied by area, stroke length, number of cylinders, rotational frequency. This is the formula. Do we have pressure? Yes, it is 750 times 10 to the power 3 multiplied by pi multiplied by 0.075 squared divided by 4. This is your area multiplied by stroke length 0.25 multiplied by C, that would be the number of cylinders, there are 3, multiply by 150 divided by 60 if this is the route that you want to take, or you can divide by, or you can write 2.5 there. Then our power, we got our power as 6,213 kilowatts. This is the power out that I've calculated. Therefore, we can then calculate power in from this formula. Now, when we make power in the subject of the formula, it will be this power divided by what? By efficiency. Divide by efficiency, 0.75. Then we get our answer as, for power in, 8,283 kilowatts. This is how you tackle question 2.2.1, this question. This is what you were supposed to have done for how many marks? 4 marks. 4 marks, good people. Applying the relevant formula, applying the given principles in calculating that. This is what you were supposed to have done. Then the second question, 2.2.2, they want us to calculate the volume of water delivered per minute. Right, if there is a slip. Now, wipe so that let's wipe so that where's my eye cursor? I don't see my eye cursor. Goodness, I don't see it. Oh, there it is. Now let's, where are we now? Why did it jump? Okay, let's wipe the bottom part so as to be able to calculate the volume of water delivered per minute. Now they want us to calculate the volume. Now in calculating the volume, it is easy. Right, it is easy. Okay. Oh. In calculating that volume, they are saying per minute. Now it will be volume equals to area stroke length multiplied by n multiplied by c. But we are then given the slip. The slip, it is 5%. What is slip? Loss of fluid or leakage. Leakage of what? Of fluid. This is what we have lost, 5%. What it is remaining? It is 95% of the content in that machine or hydraulic system. It means here you need to multiply by the actual percentage. And the actual percentage here, it will be 100 minus 5. Then we get the actual percentage of which it is 95%. This is the actual percentage that you need to use because you have lost 5%. Now, 100 minus 5, you get 95. Now, it will be pi multiplied by 0.075 squared divided by 4 multiplied by 0.2 stroke length 0.25 multiplied by n. Remember they said per minute. It means we need to multiply by 150 because n, it is given as r per minute. This is what we are given. Now, there's no need for us to convert it to seconds because they want our volume in per minute. Anyway, they want us to calculate. After calculating the volume, they want us to convert it to liters. Okay. Now it will be multiplied by what? By 3. Then multiply by 95%. It will be 0.95. Then we got our answer, or rather I got my answer as 0.472 m cube per minute. Now, in converting this to liters, you then need to multiply by what? By 1,000. Now, in multiplying by 1,000, it will be 472,159 liters per minute. Right. This is how you were supposed to have tackled that question there. 2.2.2. This is what you were supposed to have calculated there. Now, question 2.3. I don't know what's your problem on question 2.3, and many of you got it wrong. Why? I don't know. Okay. Now let's then look at 2.3. I'm scared to go to the next slide because I don't have the hard copy for me of the question paper. Only if I had the hard copy, then I would go to. Allow me to wipe, good people. I hope you got everything there. If not, pause the video, replay it so as to see how I tackled question 2. Okay, now let's wipe. Let's take out the data, the given information on question 2.3. Let's take out the data, the given information. Now, the diameter of the RAM mass loaded accumulator, we are given the DR, it is 0.4 meters. It is given as 400 millimeters. In converting it to meters, it will be 0.4. Then we are given the MR. The MR is given as 800 kgs. Then we are given the mass added. Our mass added, it is 15 rings, each weighing what? 7 kilonewton. That means it will be multiplied by 7 times 10 to the power 3. Then I get my answer as 15 times 7,000. Then I get my answer as 105,000 newtons. That's what I get on mass added. Okay, is placed on the rim. Now they want us to calculate the pressure. They want us to calculate pressure. That's what they want us to calculate. But we know that in calculating pressure, it is force over area. Do we have the area? Definitely we do have, because we are given the diameter. We can get the area. Let's do that. It is pi times d squared divided by 4. Then my area would be pi times 0.4 squared divided by 4. Then I got my area, and calculating them separately. Did I calculate them separately? No. But because of I'm making the video, I will calculate it separately. Divide by 4. Then I get my area as 0.12566 m squared. Okay, that's what I got there. We are having the first part of the formula. We then have to get the force. How are we going to get the force? We need to calculate the force from the mass total. Mass total, it is mass mr plus mass added. Now, our mass added, it's in Newton. We then have to convert it to what? To kgs. Now, it will be W equals to mass multiplied by G. Then our mass added would be 105,000 divided by 9,8. Then I get my answer, 105 divided by 9,8. Now I got my mass as 10714,286, let's say 6 kg. Now we'll then have to apply this formula for us to get mass total to be able to calculate force. Now we'll then have to add by what? By mr. By mr. Our mr, it is what? It is 800. Now in calculating that, I get my mass total as 11514,286 kg. Therefore, force would be 11514,286 multiplied by 9,8. Then I got my force as 112,840 Newton. Therefore, pressure would be 112,840 divided by the area 0.12566. Then I get my pressure as 892,952 kilopascal. This is how you tackle question 2, good people. 3 marks on question 2. Why you didn't get all of them, mina ayazi. Thank you, good people.